So this note sheet's going to start with simplifying trig identities. We're going to do some review material, and then the next worksheet will have a lot more of the simplifying on it. First thing I want to do is just identify some of the trig identities that we've already found. So things I know. I know tangent is sine theta over cosine theta. I know my reciprocal functions. So let's see. Cosecant theta is 1 over sine theta. I know that secant theta is 1 over cosine theta. I know that cotangent theta is 1 over tangent theta, which is also equal to let's see, nope, that would be cosine theta over sine theta. So I know all of those pieces. So those are all the trig identities, the ones that we're going to basically use a lot of. Now we've also got Pythagorean identities. We identified one of these back when we first started the unit circle, and it's the one that you'll hear the most often because it's probably the most well-known one. It's sine squared theta plus cosine squared theta is equal to 1. Now, this is the one I have memorized. There are two others that I don't have memorized, but I can find them. So what I'm going to do is take this original function and I'm going to create these other two. So take the first function here. So I'm going to do sine squared theta plus cosine squared theta is equal to 1. And I'm going to divide every part of this fraction by sine squared theta. Sine squared theta. Okay. So sine divided by sine would get me 1. Now I actually lined this up wrong. So I'm going to slide this over here. There we go. Now, part of what I just figured out was cosine squared theta divided by sine squared theta is cotangent squared theta. So that's cotangent squared theta. And then 1 over sine squared theta is really just cosecant squared theta. So that's one way to find this other piece. I just took all the pieces of the original Pythagorean identity and divided by sine squared. I'm going to do the same thing, but take the original function and divide by cosine squared. So let's go ahead and set up the original. Now if I take every piece and divide by cosine squared theta and another cosine squared theta. So let's see. Sine squared theta divided by cosine squared theta is tangent squared. Cosine divided by cosine, or cosine squared divided by cosine squared is 1. So that just leaves me 1. And then this is 1 over cosine squared theta, which would be secant squared theta. So you guys honestly I don't memorize these two. I just know how to generate them. So use what you need to. Now, the actual simplification, basically you want to start with converting everything to sines and cosines if you can. So I've got two pieces here. I've got cotangent theta and secant theta. So cotangent theta is going to be cosine theta over sine theta times secant theta is 1 over cosine theta. Now cancel out what you can. All right, so cosine theta will take out that cosine theta. We are left with 1 over sine theta, and that can be reduced to a single trig ratio of just cosecant theta. So that's simplification. Let's see if we can do it again. So problem number 6, I'm going to leave cosine theta as cosine theta. It is already in terms of sine and cosine. Tangent theta, I can change into sine theta over cosine theta. Cancel what you can. So cosine theta would cancel out cosine theta, and what would be left is just sine theta. Now, you're not always going to be able to take it down to a single trig ratio, but if you can, that's the point that you want to get to. All right, number 7. number 7, I'm going to distribute. So I'm going to take sine theta cosecant theta minus sine squared theta. Let's see, sine theta, cosecant theta is really 1 over sine theta minus sine squared theta. So sine theta divided by sine theta, those are going to cancel, divide each other out, and I'm left with 1 minus sine squared theta. This can be further reduced. As soon as I start seeing things that have 1 minus or 1 plus some trig function squared, my brain goes to one of the Pythagorean identities. That's going to be something I'm going to need. Now, this one uses sine squared, which, hey, look, I've got a sine squared here. What I don't have is 1 minus sine squared. So what could I do to this Pythagorean identity to get it to say 1 minus sine squared? Well, I could subtract sine squared from both sides. So if I take the original identity, and I'm going to put it up above number 7 here. So if I did sine squared theta plus cosine squared theta equals 1, and I subtracted sine squared theta from both sides. So that's going to get me cosine squared theta equals 1 minus sine squared theta. So 1 minus sine squared theta is equivalent to cosine squared theta. That's going to be what it will reduce all the way down to as soon as I can write it correctly. So there's cosine squared theta. All right, problem number 8. Let's go ahead and see what's going on here. Now, the nice part is we just talked about what happens with 1 minus sine squared theta. Now, once you've done it once, you've done this math to show it works for yourself, just keep using it. So this is going to stay, well, actually, no, that's not going to stay. Secant squared theta is 1 over cosine squared. 1 minus sine squared is really cosine squared theta. So these cosine squareds will cancel out, and that whole expression is just the number 1 because everything divides out completely in problem number 8. Let's see, problem number 9, we've got what's going to turn into a complex fraction. Now I'm going to do number 9 as a complex fraction, and then I'll do number 10, which is a similar kind of problem, but without turning it into a complex. So cotangent theta is cosine theta over sine theta, and then cosecant theta is 1 over sine theta. This is all a bunch of division. So cosine theta divided by sine theta, all divided by 1 over sine theta. So to get rid of this denominator of 1 over sine theta, I'm going to multiply by its reciprocal, which is just sine of theta. What you do to one part of the fraction, do to the second part. So sine theta will take out sine theta, which really will eliminate this whole denominator here. Same thing will happen here. Sine theta takes out sine theta, and all that's left after all of that is just cosine of theta. That's if you want to deal with this as a complex fraction. Remember, complex fractions are just fractions made up of fractions. Now, if you're looking at that going, I don't like that. Okay, that's fine. Problem number 10, we've got cosecant theta divided by secant theta. So let's see, if we set up cosecant theta divided by secant theta, and we solve it this way. So cosecant of theta would be 1 over sine theta divided by secant of theta is 1 over cosine theta. Now, if you remember how to divide fractions, you don't actually divide fractions. You multiply by the reciprocal. So 1 over sine theta times cosine theta over 1, multiply straight across. Actually, I'll just put this below it. So this is going to become cosine theta over sine theta, which can be reduced to a single ratio of just cotangent theta. So we're going to do a lot of practice with simplification. I hope this makes some sense. And if you do have any questions or concerns, let me know. The rest of this sheet is all review.